Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to talking about multiple access protocols, that is part 3. In previous session, we already discussed about what are the different multiple access protocols like random access protocol, control access protocol, channelization protocol. These are the different types of multiple access protocols. In that, we are going to discussing about what are the different types of control access protocols and channelization protocols. See, these are the three types of the multiple access protocols. In previous session, we discussed about these all random access protocols. Again, in that, we are going to discuss about Aloha, that is pure Aloha and starter Aloha. Next, we discussed CSMA, CSMA over CD, CSMA over CA. This all we discussed in previous session. Now we are going to discussing about what are the control access protocols. Those are reservation, polling and token passing. These three we are going to discussing in today's session. Next, we are going to discussing in today's session what are the channelization protocols like FDMA, frequency division multiple access, TDMA, time division multiple access, CDMA, code division multiple access. These three also we are going to discussing in today's session. First, let us see what are the control access protocols. First one is reservation. What is reservation? In real time, where exactly we use the reservation when we are booking some railway tickets, we are going to use this word, right? For reservation purpose, we are going to use railway tickets, we are going to use the reservation. See, here how it is going to be applied for the control access protocols, the reservation is the station need to make a reservation before sending the data. Suppose this is a channel. When the channel wants to, when some particular station want to, these are the different stations. These are all the stations. Whenever these particular station want to send the particular data to this particular channel, first it will resort to this particular channel before sending the data. Means if this station want to station 1, 2, 3, 4, 5, this particular station 5 wants to share some data using this particular transmission medium. Before sending the data, first it has to reserve the seat. Then only it will send the data to this particular channel. That is nothing but the reservation. In each interval, a reservation frame precedes the data frame sent to the interval. Means each interval, the reservation frame is going to be precedes the data frame to the sent. Suppose if there are n stations, here the number of stations are there. In that particular system, there are exactly n reservation mini slots are there. Suppose if number of stations are n are there, then the reservation slots also mini slots are going to be n mini slots are there in the reservation frame. Suppose this is the frame, n station wants to send the data. So, a number of mini slots are going to be there in that particular system. That is a reservation frame. So, each mini slot belongs to the station. Each belongs to one station. That is about the frame, reservation frame. When a station needs to send a data frame, suppose this station wants to send the particular frame, it makes the reservation its own mini slot, in its own mini slot. Suppose this one wants to send the data. So that time what it will do? It makes the reservation in its own mini slot. That is nothing but the reservation. The station that have made reservation can send their data frames after reservation frame. When it is going to be reserved, then that time only it will send the data after the reservation frame. See this picture, that will be very clear. First, this is the data station. This is another data station 4, 3, 1, like that. These are the different stations. This is nothing but the reservation frame. This is the reservation frame. What it will contain? Reservation frame is having the number of stations, right? So these are the 1, 2, 3, 4, 5. These are the stations, n stations. Each station is having their own mini slot. This is nothing but their own slot. This one is having the slot, 2 is having the slot, like that. It is having their own mini slot. Each station is having their own slot. So suppose what yellow color is indicating that it is ready to send the data. 2 station it is not ready to send the data. 3 is ready to send the data. 4 is ready to send the data. 5 is not going to ready to send the data. See here, 1 is ready to send the data means it is allocated to station 1. So again 3 is going to be allocated to station 3 means for sending the data. Next 4 is going to allocated to station 4 for sending the data. 2 and 5 not going to allocating for any data because they are not ready for the sending the data. And next coming to this frame, reservation frame, here these 2, 3, 4, 5 all are not ready for sending the data. Only one frame is ready to send the data. So it is allocated to station 1. Like that it is allocated to each and every station. So suppose take this example reservation frame. Here all are 0 means there is no one is ready for sending the data. Means it is not allocated to any data station. That is about the reservation. Means before sending the data, we have to reserve first. Then only we can send the data. That is about the reservation. And next one is the polling. What is polling? Polling in classrooms also we are applying polling, like where we are applying exactly polling means from that particular we have to select one student has the Miss CR class representative, like that means in that particular students, these are the suppose total number of students are there. In that all number of students we are selecting one as the class representative. Same here also we are using the polling. See, polling protocol is mainly talking about one of the nodes to be designated as the master node. Here the number of nodes are there. In that one node we have to select as the master node. That is the polling. This is the primary station. This is the primary station. To that particular master node only we are sending the data to means this master node giving a chance to each and every station for sending the data using the round robin fashion. How round robin is going to be work? Round robin condition mainly for what? For each and every station, what we have to do? For each and every station, we have to allocate some time bound. Time bound is there. Means for every station, we are giving some 2 minutes time for sending the data. That is the condition of round robin fashion. So, master node is giving time to each and every station for sending the data. Means based on the time slot. That is the round robin fashion. So, the master node first send the message to node 1. Suppose this is the node 1. First it will send the data, it will send the message to the node 1. So, after if the chance comes to node 1, what it will do? If the time bound is 2 minutes, within the 2 minutes, how many maximum number of nodes you can calculate? Then after completion of 2 minutes, again it will get the master node gives the chance to the next station. That is the condition. Master node gives the next station. If process continues this manner, the master node is polling each and every node in a cyclic manner. Means like that this master node giving the chance to each and every node. After this node, it will give the next node, then it will give the next node, then it will give the next node, like that. Every 2 minutes it will going to be finished to each and every station. For sending the data within the 2 minutes, whatever possibility for sending the data maximum number of nodes, it will send the nodes. That is the condition. It is going to be happen in a cyclic manner. It will move to the all over nodes. The polling control eliminates the collision. Like that, it is going to eliminate the collision also. So, this allows polling to achieve the much higher efficiency. Here, efficiency also more. The drawback of this polling technique is the protocol introduces the polling delay. Sometimes it may happen to polling delay also. What is the main aim of polling delay? How it is going to be drawback here? The amount time is going to be required to notify a node that it can be transmitted. Means the master node only has to select which node I have to send, like that. Here the polling delay is going to be happen for selecting the node. That is the drawback. And next second drawback is which is potentially more serious. How it is going to be serious? See here, if the master node fails, suppose who are giving all chances to the all other nodes, master node is giving the chances. If suppose master node is going to be failed, the entire channel becomes inoperative. Means the entire channel is going to be inoperative. That is the second drawback in the polling condition. This is about the polling channel addition protocols, control access protocols. And next one is the token passing. What is token passing here? Means we have to give 5% to each and every station for sending the data. Means whenever suppose this is the channel, if this using this particular channel, if the stations want to send some data, first suppose this one wants to send some data using this particular channel, it will have the token. Then only it will send the data. That is the token passing condition. The station is authorized. Suppose this station is authorized to send the data. When it receives the special frame, when it's going to be receive the special frame in the token, then only it will allow to send the data using this particular channel. There is no master node. In previous condition polling, there is a master node, but here there is no master node for sending the data. A small special purpose frame is known as a token. So whatever token is there, that is called as the special purpose frame. The token is going to be exchanged among the nodes in some fixed order. If this token is also having some fixed order, then that order only we are giving to all other stations. When you know this is a token, suppose this one received a token, it holds onto the token only if it is has some frames to transmit. Suppose this one station wants to send the data. If it is having the frames, it will send the frame. It will send all the frames. Then it will go to the next token. It will give to the next station. Means it will immediately, suppose all frames are going to be completed. Then immediately it will forward to the token to the next node. That is the condition. For that, we are going to use the token passing. This is the token passing mechanism. Suppose this PC first is having the token. After completion of all frames, it will give the token to the next. Again, it will give the token to the next one. Again, it will give to the next one. Like that, it will give the token to the next one. After completion of half, it will give the next token. Next station, that is the condition of the token passing. And next one is the channelization protocols. What are the channelization protocols? First, what is channelization? Channelization is nothing but multiple access protocol method. Is mainly talking about the bandwidth of the link. It is mainly talking about the whatever channel we are going to use. That is mainly talking about the bandwidth. This is about the bandwidth is nothing but the capacity of this particular link. Mainly it is talking about the time, frequency and code. Based on this, we are going to send the data between the different stations. Based on time, based on frequency, based on the code, we are going to send the data between the different stations. Mainly it is talking about the bandwidth of the particular link. See here, in that what is multiplexing? Multiplexing is talking about multiple signals. These are the multiple signals. These all signals are going to be combined and are going to be combined together that can be traveled simultaneously to a shared medium. Is nothing but the multiplexing. All signals are going to be combined together, then only it is transmitting to the shared medium. Is nothing but the multiplexing. This multiplexing is mainly talking about what? Sharing the bandwidth. Means we are sharing the bandwidth. That is the multiplexing. It is going to be divided into three types. This channelization is going to be divided into three types. First one is the FDMA. FDMA is nothing but frequency division multiple access. And next one is TDMA. TDMA is talking about time division multiple access. And next CDMA is talking about code division multiple access. That is CDMA. So first we will see what is FDMA. FDMA is talking about frequency. Mainly it is talking about FDMA is talking about frequency. What is frequency? Division multiple access. In FDMA, the available bandwidth. Mainly already we told channelization protocol mainly talking about what? Bandwidth. Bandwidth of the particular link channel. The bandwidth of the common channel is going to be divided into different bands. Whatever channel, this is the channel. This is going to be divided into different bands. That is the FDMA. That are separated by guard bands. Whatever channel is going to be divided into, that is going to be divided into bands. These bands are separated by what? Guard bands. These are going to be separated by band bars. Suppose this is a channel. This channel is going to be divided into different what? These are the bands. These bands. So these are going to be separated by guard bands. These are nothing but the guard bands. So the available bandwidth is shared by all stations. Whatever bandwidth is there, it is going to be shared to the all stations. In this FDMA, it is a data link layer protocol. Frequency division multiple access is the data link protocol, but it uses the FDMA at the physical layer. Means the first layer is what? Physical layer at inverse reference model. Frequency division multiplexing is talking about the physical layer, but frequency division multiple access is talking about in data link layer. See how it is going to be transferred data by using FDMA. See here, this is a channel. Each it is going to be divided into different bands. These are the bands: channel 1, channel 2, channel 3, channel N, like that. It is going to be divided into bands. These are going to be separated by these guard bands. Why we are using these guard bands is nothing but to avoid the collision between the channels. We are going to use these guard bands for avoiding the collision. We are going to use the guard bands. This is about the FDMA. See here, this is the diagram for this. Each and every station individually want to send the data. These are the different stations are there. Here it is blue line, yellow, green and pink line. These are the lines. Each and every station is having their own frequency for sending the data. That is the frequency division multiple access. Means the channel is going to be divided into different guards, means bands for sending the data. That is about FDMA. And next one is the TDMA. Based on the time, Means whatever bandwidth is there, that is going to be divided in the form of time. In TDMA, the bandwidth is just one channel. It is a one channel of that time. The time is going to be shared different time stations. Means for different stations, we are giving the different time for sending the data. That is the TDMA. The entire bandwidth is just one channel. Total bandwidth is one channel only. That we are allocating to the different stations at different time. Stations share the capacity of the channel in time. How it is going means, for each and every station we are allocating time slot. Based on the slot only it will send the data. That is time division multiple access. So this is the time. Based on the time we are allocating. This is a channel. We are allocating each and every station for different timing. That is about TDMA for sending the data. And next one is the CDMA. CDMA is talking about what? If the one channel carries the all transmission time and simultaneously, we are going to use the code division multiple access. How it is going to be differ from the FDMA? CDMA means code. It is talking about frequency. How it is differ from the FDMA means, because only one channel occupies the entire bandwidth here. Means only one channel is going to be occupies the entire bandwidth of the link. That is the CDMA. And how it is going to be differ from the TDMA means time division multiple access. How it is going to be differed? CDMA is how it is going to differ from TDMA means, it because all the stations can send the data simultaneously. Means here it is talking about the frequency. Only one channel occupies the entire bandwidth. Here all stations can send the data simultaneously in TDMA. Means there is no time sharing. Here in CDMA there is no time sharing. That's why CDMA is different from the TDMA. This is about CDMA. So coming to the summary, in today's session we discussed what are the control access protocols like reservation, polling, token passing. These are the control access protocols. And next we discussed channelization protocols. Those are nothing but FDMA, that is frequency division multiple access. And next we discussed TDMA, time division multiple access. And next we discussed CDMA, code division multiple access. These all we discussed in today's session. Till now we completed multiple access protocols. Multiple access protocols. Multiple access protocols again divided into what? Random access protocols. Randomly we are selecting the channel is nothing but random access protocols. Next we divided into controlled access protocols. Those are nothing but these reservation, polling and token passing. Next we discussed channelization protocols. These are nothing but the FDMA, TDMA and CDMA. These are all about the MAC protocols in data link layer. Thank you.